Good evening, students. Okay, so if you remember yesterday, we tried to solve a problem which was on a ball which is released from the top of an inclined plane. You release a particle from here. Okay, it's not writing. Just a minute. Yes. Okay. So you release the particle from here. As you see, the particle started sliding down, and when it reached over here, it reached this point. The question that I asked here was, what would be the velocity? So towards it, what we did was we considered the misconception which students usually do it is that since the initial velocity is 0, there are two distances given, S1 and S2. So what they do is they consider something like using this equation. So they either put S1 is equal to something like 4 meters, or sometimes some students put it as 5 meters. Okay, and finally they get the answer. And yesterday what I did was I did by both the methods. And I said that, okay, you get one from here, you get another from the other one here. So this is completely an incorrect version. And this one, okay, I also said this is incorrect. But finally, when we got the answer, we got a different answer. We got the answer which is the same as what we got if I put S1 equal to 4. But I did not tell you about why this should be put as 4. Okay, the logic was not explained. Now let me help you out. Let me explain, okay, why this method also gives you, that is by putting the value of G equal to 10 and S1 is equal to 4. Why do you get the same answer as compared to here? Or is the method correct? Okay, that's what we need to look at. Okay, let me go to the next slide. Now, I have removed those red ink marks that I have written. Let me retry. Let me briefly explain what we have done earlier yesterday. We took an inclined plane and then we had a particle here. The particle moved. The reason is because there was an acceleration, which is g sine alpha. This was your alpha. And I said that the length of the plane is 5 and this value is equal to 4. So this should be 3. That's what, if you refer to my previous video, you will get to know. And then what I did was I just used S is equal to ut plus half at square. And I consider this as my x-axis, this as my y-axis. And towards it, I put u equal to 0. And then I put a half, and a is nothing but g sine alpha into t square. T square, sorry, we didn't use, did we use this? No, we didn't use this one here. I'm sorry. We didn't use this one here. We used, because we want to find out the velocity here. I just did v square equal to u square plus 2as, and I put u equal to 0 plus 2 into the value of a is nothing but g sine alpha. And the value of s, I have used it 5. Okay. And finally, I substituted all the values. I got 2 into 10 into sine alpha here is nothing but 4 by 5. 4 by 5 multiplied by 5. So I got the answer as 80 here. Okay, I assume this to be nearly 81. And thus I got the value of V to be equal to 9 meters per second. This is what I got. Now the next question is that, okay, now let us say I use the value of S equal to 4. The second method, this is my first method. Method 1. Let me use the second method. The second method, what I do is, so here we use this formula and the value of A is g sine alpha is nothing but the acceleration along the plane, and that's why I took this as my distance. Now the question that comes to me is, hey, if I have taken this distance, I took g sine alpha. Now if I take this distance, vertically downward displacement, then should I use g sine alpha? Not necessary. Okay, so you should just use the value of g itself. That's the reason why when you use v square equal to u square plus 2as and you put u equal to 0, and next what you do is 2 into a. Okay, what is a here? A vertically downwards is g. See, it's vertically downwards is g. So I'll write this as g, and this s. What is the s here? If I am considering the force along this direction, I should also consider the displacement along this direction, the vertical y direction. So therefore, the value of s here would be 4. So making use of this, now what I do is 2 into 10 into 4, which would be equal to 80, which you get, and thus v is equal to nearly 9 meters per second. If I put this as nearly 81, I get the answer 9 meters per second. Now the question once again I pose, okay, because you know we should understand the concept. I didn't teach you this initially. The reason is because this could lead to several errors if there's a slight modification. I'll tell you what modification we have. Let us say, for example, this inclined plane also has some friction. If it has some friction, then this answer will not match with this. If you want, I can give you an example also. Let us say the coefficient of friction here is something like 0.1. Okay, I'm giving you as 0.1 over here. In that case, your net acceleration will now be, so your problem now becomes something like this. I made the problem much more complex. So now this will become g sine alpha is your acceleration downwards, and there's a upward a frictional force. When you say there is a frictional force, there is also a frictional acceleration. How do you get that frictional acceleration? Let us say FF is a frictional force. We know that FF divided by M. Why FF divided by M? This should give you the frictional acceleration. Why is it so? Because we know F equal to M into A, Newton's first law, second law, right? So therefore, you can get the frictional acceleration here. So therefore, this should now become AF over here. Now, how do you determine this value of AF? We know that this value is N. This value is mg cos theta or mg cos alpha. If this is angle alpha, then you can write this as N is equal to mg cos alpha. And then we know that the frictional force FF is equal to mu times N. What is this value? This should be mu times mg cos alpha. Now what do I need? I need this acceleration. So this acceleration AF should now be equal to FF divided by M, which should be mu g cos alpha, which should once again be, now let us substitute this value. This 0.1 multiplied by 10 multiplied by cos alpha. Cos alpha ka value kya hai? See, cos alpha is 3 by 5. See, adjacent by hypotenuse. 3 by 5. Now when I do this, 5 1s are 5 2s are, you get the answer to be equal to 2 into 3 into 0.1 should be 0.6 meter per second square. Okay. So therefore, now the net acceleration that you get over here is not just g sine alpha. It would now be A dash should be equal to g sine alpha minus frictional force, right? Frictional acceleration. Okay. So this would be your net acceleration. So therefore, but you will not get the same answer, but you might get a different answer. Let us work it out if you want. This is a 10 multiplied by sine alpha. What is sine alpha? 4 by 5. 4 by 5 minus 0.6. So what will you get here? This is 2 4s are 8. 8 minus 0.6 should be 7.4 meter per second square, right? So substituting this value, you get the value as V square is equal to 2 into 10 into 7.4, 7.4 into 5. Am I right? Okay, now let us find out what is this value, which should now be equal to 5 into 2 is 10, 10 into 10 is 100, 100 into 7.4 should be nearly 70, 740, you get it, right? I hope I have not made any mistake. 7.44 by 5 into 5 is 4 there. Just let me check it out. Yes. Okay. 5 into 2, 10. 10 into 10 is 100. 100 into, I made a mistake somewhere over here. 10 into 4 by 5 is 8. 8 minus 0.6 is 7.4. Correct. 740, 74 into 100. I'm getting 7.4 into 100. Which is 740, you get it over here. Array, I made a mistake somewhere here, I think. It should be 2 into 10 into 5. 5 goes away, 2 into 4, 80, 800. 880, you get it correctly here. Now 2 into 10 into... I made a mistake here, substitution. 2 into A dash, which is 7.4 into 5. See, this is where things go wrong, which should now be equal to 2 into 5, 10, 10 into 7.4 should be 74. Kabhi kabhi मैं भी गलत करता हूँ. V is equal to square root of 74. What is the value of root 74? We are calculators. We are all got addicted to calculators, is it not? Okay, root of 74 is 8.6. You get the answer as 8.6. Okay, what is the unit? Meter per second. Physics may unit is very, very important. Okay, so here you got around 9 and here you got around 8.6. Note the difference. Okay, so every time this shortcut will not be applicable. Okay, that is what you call it as misconception. When we do it on the board, we assume, okay, array, when the teacher has done like this, I can also do it for anything. But if the friction is given over here, then you should not go by this method. Okay, the easiest way to do it is understand it like this. When the particle is sliding along an inclined plane, find the acceleration, find the velocity, everything along the inclined plane direction only, along the motion of the particle. Don't assume it in a otherwise direction. If you do it, you will be making a mistake. Okay, I hope I have helped you out by solving this problem in a different way and also told you what are the limitations of this problem. Okay, thank you friends for watching this video. Like, share, comment and subscribe to my channel so that your word of appreciation will always help me out to make more such videos. I am always looking out for such kinds of content. Okay, instead of teaching every problem, so what I do is I just look at where do the students make mistakes in such problems, where should the concept be more emphasized, and this is what is the result of it. Okay, so see you tomorrow once again. Thank you.